All right, I'm about to break some rules here. I don't really like necessarily the way that they do their teaching how to graph these. I would do this a little differently. By the way, for as long as I've taught math, I've always considered this standard form, but this textbook that we're using does not consider it standard form, so that's a whole other issue. But starting though, we do start similarly in how I approach this and how the book approached it. And there's not like a right or wrong way. And so uh, and also, don't let me forget, I got to do domain range. All right, first off, I'm going to look at the leading coefficient. Okay, and that's the number in front of the highest power. And I'm going to see if it's positive or negative. It's negative, so that's negative. So that means it's going to open downward. Okay, that's kind of like we saw earlier. So it's going to be an N-shaped. Okay. Next, we're going to look and find what we call the axis of symmetry. Okay. And so we're going to use that to find the vertex. So I'm going to use a formula, x equals negative b divided by 2a. This is called the formula for the axis of symmetry. And what the axis of symmetry is, it's basically an imaginary line that would cut the graph in half, okay? And so now I've got to identify what b and a is. B is the coefficient of the x. So b is 4. A is my leading coefficient. Leading coefficient is the one in front of the squared, so that'd be negative 1. So 2 times negative 1. Negative 4 divided by negative 2 would be positive 2. So that's my axis of symmetry would be x equals 2. Now, why am I doing this? Okay, what does this do? Well, what this does is axis of symmetry is a line that cuts in half. That tells me where my vertex, where the x is on the vertex. It's going to kind of tell me where the center of my graph is going to be. Now, I'm about to break some rules here. I'm not going to do it the way they do it. I'm going to do this by making a table. Okay, I'm going to do this by making a table. And so how I do this is I'm going to put this x, whatever this x is going to be the middle of my table. And I'm going to use 5 points. And so I'm going to pick two x's that come before 2. I'm going to pick 1 and 0. And then I'm going to pick 2 that come after that. So 3 and 4. And I'm going to find the corresponding y's. How do I find the corresponding y's? Just plug in the x's, okay? So plug in the x's to my function. Okay. I'm kind of overdoing it here. You don't have to show this much work, but I'm just showing you how this is calculated, and I can also show you in the calculator. Hopefully I do all this right. Oops, see, I already messed up. And I didn't mean to put a negative 2 there as well. I apologize. See, I get a little carried away here. So negative, and this is going to be negative 3 squared plus 4 times 3. I didn't mean to put a negative 3 there. Fun game here. This is positive. This is 3 squared plus 4 times 3 plus 1, and then negative 4 squared plus 4 times 4 plus 1. Okay? So I'm going to figure out what these values are. I can type them in your calculator. And there's also another way to do this too. I'm going to show you. So I can go to second mode. I can do negative 0 squared plus 4. You notice, remember I've talked about when I plug numbers in, I put parentheses around it. And there's a reason why I do that. This is 1. I'm going to go up here and press enter and grab that. Just put 1 in this spot. This is 4. Enter and press 2 in that spot. 5. And then 3 in its spot. That's 4. And 4 in this spot. Now, as you notice, you're going to see some symmetry here. Okay, you should see some symmetry. Notice you see symmetry there. Okay, like these two correspond. If you're doing it right, that's a good sign. Now, how can you cheat on this? You can go to y equals negative. Remember, negative's down here. And I do x squared plus 4x plus 1. And I can go to second graph. And look at that. 1, 4, 1, 0, 1, 1, 4, 2, 5, 3, 4, 4, 1. And so I could plot those points. Okay, so 0, 1, 1, 4, 2, 5, 3, 4, and 4, 1. Okay, so there's a look at my graph. Then I'm going to go connect these dots kind of in a, remember you go round it around there. And so this is called using a table. I could have done this method kind of on the last one if I wanted to. I kind of like this way better for this type of problem. You could also look at graph to check your answer, make sure you're doing it right, make sure both of these things align on the same page. Now, don't forget, they also asked for domain and range. And so let's talk about that. Domain, we ask ourselves, and we'll use interval notation. How far left to how far right? So how far left will my graph go? Well, it's going to go forever to the left. Okay, so it'll be negative infinity. We put parentheses for infinity because infinity is not an exact location. How far right does it go? Well, it goes forever to the right, so positive infinity. Range, how far down does it go? Range deals with y. How far down does it go? Well, it goes to negative infinity. How far up does it go? So now range we're doing in terms of y. So how far up does it go means I'm looking at the highest point, I'm looking at the y. So the highest point, the y at the highest point is 5, and then it's exactly 5. So I'm going to put a brace there. So there's my domain and range. And remember we said it was negative. It's going to open downward, and it opened downward. And so that, hopefully that helps you on that.